And welcome back, everyone. Samuel is back here, and I'm here with Colby. Colby, thank you very much for being with us. I hope you enjoy it as much as we do. How are you doing?
I'm good. Thanks for having me here.
It's our
I'm
pleasure.
excited.
So I know that you are on the other side of the Atlantic Sea in United States, right?
Yep.
So, like, if COVID is not enough, now you have other issues, right?
Yeah. Yeah.
So, how are things in United States now?
It's been challenging. A lot of people are suffering, so it's understandably people are upset about it. So just hopefully it's the start of some good change. But it's definitely been challenging.
I hope everything goes well very soon
Yeah.
for both for all of us, right?
Yeah.
So, are you ready to start?
I'm ready.
Okay, I will over it to you. Thank you very much, Copy.
Awesome. Thank you. Hey, J Nation. Today I'm going to talk about maps. We'll talk about the impact they can have on the world, and we're also going to dive a little bit in how to build them with JavaScript. So who am I? I'm Colby Fayock. I'm the one hugging BB-8 and Kylo Ren over there. I work on the UX and front-end side of things at Element 84. You can find me pretty much anywhere on the web by just Googling my name, as I'm the only one in the world. So looking at this first slide, it's a screenshot of Google Maps in downtown Alexandria, Virginia, here in the United States. This is Element 84's HQ. We're all probably pretty familiar with Google Maps or Apple Maps. They provide us with a lot of features we use every day. Like here, we can check out some points of interest nearby. We can find where we can grab a quick cup of coffee or find the best sushi, which is Momo Sushi if you're in town, or we can just look at some of the pictures of the area. This next screenshot is public transit directions. It's showing the metro that I would take from getting to my last apartment to work. I just recently moved, hence the boxes in the background. But my wife and I share one car, so when I didn't have it, I was able to get a good idea of how long it would take to get downtown. This next one shows some driving directions. This is the route I would take to get to my mom's house where I grew up. The time here is a little optimistic though. It never actually took 4 hours to get there with traffic. So how many of you all like to travel? As much as we'd all probably love to be in another country every month, that's usually not feasible, especially now. So my wife likes to take virtual vacations around the world, which is also a little bit better for our budget. But Google Maps lets her easily travel around the world and check things out. Here we're getting a great look at the Great Pyramid of Giza. We can see an overhead view from above and get an idea of what this area looks like. The cool thing about this, though, is we can get the close-up look with using Street View. We can actually get an idea of the scale of this thing. It's huge, and we can get an idea of how big it really is. When I was talking to my wife about this, she was actually in the middle of one of her journeys. She wandered to a place called the Valley of Geysers, which is located in Russia on the Kamchatka Peninsula. It turns out that this geyser field has the second largest concentration of geysers in the world. It seems wild to me that we can get a look at this place, and it's all because somebody took the time to take a picture of this remote area. This particular picture was from a local guide, so really any of us can do this. But the neat thing is we can check out this kind of place even if we'll never have the opportunity to go. It's obviously not the real thing, but we're still able to get a glimpse of remote places all around the world. So where do we actually get the data to build out these kind of features? Well, first you have the obvious one, scientist and analyst. This is just a stock photo that I found from GIS University, but they're constantly hard at work collecting and processing data. I have to hope, though, that they always look this happy. And you also have technology. Thanks to the cars and the people that build Street View, we get a close-up look of the pyramids. This also includes a ton of people around the world, like I showed in Russia. There are local guides all over contributing to the pictures and the data. But we get some Easter eggs, and thanks to Tokyo, we get ones like this that are all around the world. But then we have satellites. There are a bunch of different types. Some collect imagery, some collect more in a data format, but they all help to produce the assets that we use to create our maps. A good example of this is Cryosat from ESA. It uses its onboard instruments to measure changes in ice thickness. It can actually measure as accurate as 0.7 centimeters per year. The example on the right is showing Antarctica mapped out in 3D using the data that it collected. Another example of this is NASA's MODIS Terra. MODIS stands for Moderate Resolution Imaging Spectroradiometer. Using its image sensors, it can collect every point on the Earth every 1 to 2 days. It collects large-scale global dynamics like cloud coverage, ocean processes, and changes in atmosphere. The shot on the right is a photo of Lake Erie in the United States. NASA alone is working on all the ones you see here. They published this image to show the state of their missions operated by their Earth team. It shows satellites in orbit now and out through 2023. But NASA and ESA aren't alone here. There's thousands of satellites like those flying over us right now. Some of them aren't even working, but a lot of them are collecting images and data about our planet. These satellites are also cool from a consumer point of view. NASA and other teams put pictures up on Instagram for our daily dose from above. At the top, you see the International Space Station, which isn't necessarily a satellite, but it shows the Earth at night, which I just think is cool. The bottom is from Daily Overview, and it gives us a look at Lake Natron in Tanzania, which is just mind-blowing. Then on the right, we have Gorgeous Look from NASA Earth, which is a picture of Murgui Archipelago, which is on the border of Burma and Thailand. It's just awesome to be able to see these kind of inspiring pictures right for your Instagram feed. But switching back to maps for a second, this is just another look at downtown Alexandria where I work. But behind that, it's OpenStreetMap. OSM is an open source project. It maintains a huge set of metadata that includes the attributes and properties that define specific geographic areas. It allows mappers all around the world to contribute. So with their tooling, anyone can identify points of interest or update features. With our powers combined, this also means that another source of the data is you. But millions of people all around the world have mapped on OSM. There's meetups and communities all over, and others just work alone as individuals. But thousands of people work on this every single day. You also see big companies who use this or contribute back to OSM, like Apple uses it for regions where commercial data isn't available, and Lyft also contributes back with their work. They're all adding points of interest and drawing streets, and it's more for just learning about what's in the US or in Portugal, but third world countries all around the world. This is incredibly helpful from a humanitarian aid perspective. Here we can see an identified refugee camp on the border of South Sudan and Ethiopia. A lot of time, people in these areas might not know where they can be safe, but OSM allows people to identify these features that can help others survive. So where am I going with this? The point I'm trying to make here is that these maps are more than just driving directions. Maps are literally giving people tools to help save the world. There's tons of research going on in many different areas, from climate change to agriculture. By taking collected data and applying it to a map, we're providing another visualization medium for scientists that can actually make a difference in people's lives. Some examples that you can find online are services like NASA's Worldview, where here we can see Tropical Cyclone Idai, which is one of the worst cyclones on record to affect Africa and the Southern Hemisphere. It affected close to 2.2 million people in Eastern Africa. It's insane to see the scale of the storm. Another is NASA's Firm service. It allows you to see active fires all around the world. Here we can see a cutout of the Australian bushfire wildfires. We can see the number of active fires in each area. There were devastating losses from this disaster. But tools like this help teams manage resources for determining how to help in these scenarios. And for something pretty current, which is why we're all online instead of Queenborough, hopefully I said it that right, we can take a look at the map from Johns Hopkins University. It shows the number of coronavirus cases around the world. Showing the visualizations like this on the map help people identify the larger areas of impact. Similarly, the map from NextStrain shows the evolution and spread of the virus. If you visit this page, you can actually play an animation that shows how the virus spread. These types of tools are incredibly helpful for anyone in the science community that's trying to study and understand more about the virus. But on a lighter note, people are also doing some fun things with maps. We're here, radio.com, they have a map that lets you select a country and a time period. So I can listen to music from Portugal in the 50s or Brazilian music from the 30s. But there are a ton of well-known teams doing great work to help. These are some of the ones from the United States. We have USGS that's helping map out earthquakes. We have USDA that's monitoring food access. And they're not just monitoring the United States, they're monitoring all around the world. They're helping work towards providing more information for the people who can actually make a difference, which is directly translating to lives saved. So how does this actually work? It definitely can seem intimidating. There's a lot of information there. But getting started probably isn't as bad as you think. So let's break it down a little bit. Mapping applications look like a standard JAMstack app. For those unfamiliar, JAMstack sites are JavaScript APIs and markup. It's pretty much a static HTML website, but utilizing JavaScript in the browser to make any requests to your APIs that would provide dynamic data. It's not necessarily a new idea, but the architecture's got a cool name now, which also comes with some cool references and memes. But the JAMstack concept is pretty much what you're working with out of the box with maps. First, you have the JavaScript that makes the map and the libraries that load the map run. Layered on top of that are your APIs, which for maps look like the underlying imagery and anything you put on top. That compiles down to your markup, which the output is your standard HTML. That ultimately gets served to the person who's using the app. So let's start on the top with JavaScript. We're going to look at Leaflet. Though it's not the only tool available, it's the most popular mapping library available. Here we have a really simple example of a map that we get from Leaflet's homepage. It's pretty basic, but on top of that, we have a simple marker and a pop-up. Behind that, we're using OpenStreetMap, if you remember from before. That's providing our base map layer. So how do we get there? Believe it or not, this small snippet is all it takes, so let's break it down. From the top, we create a map instance. That map instance takes an ID, which is the ID of the div that we're mounting on. Next, we set the view of the map using latitude and longitude. We also set a zoom level that allows us to determine how far into the map we're actually zoomed. Next, we describe the layer that we want to add to the map. This is called the tile layer. I'll go over tile layers in a little bit, but we set up a new tile layer instance using an endpoint URL. We also provide an attribution to give the service credit. So this is going to give us the base of the map, but how do we get that marker? This last snippet creates our marker. Using a Leaflet marker instance, we set the position of where we want the marker to be using that latitude and longitude again. Then we bind a pop-up to that marker with some simple text, and we continue to open up in its place. And after that, we have our map. So if you're anything like me, you like to build your applications in React. So luckily, we have React Leaflet, which is a library that takes Leaflet and builds out native React components to help quickly build maps. Here we have an example that's shown on the React Leaflet homepage. If you notice, it's actually the same map that we saw before, but now it's using React components. Breaking this down again, we have our map component that wraps everything. We set our latitude and longitude using the center prop, and we set our zoom with the zoom prop. Inside our map, we have a tile layer component. There we add our endpoint and an attribution. Then we add a mark component. We set the coordinates with the position prop. Inside that, we include a pop-up component, which we then nest our simple text. And again, we have our basic map. And if you're not a React fan, there's definitely some other flavors of Leaflet available. Angular and Vue both have libraries to help you get started. Unfortunately, though, I couldn't find a logo of Angular with the Leaflet mashup like Vue. But while React provides a good base to get things started, the real magic is working with the Leaflet API. The way Leaflet works is by attaching itself to the browser window. This is probably less common than it used to be. We're mostly using modules now. But once we have our component mounted, we have access to all the Leaflet APIs, where we can create maps not of this world, like this example here. But that kind of thing isn't without its ups and downs when trying to mix it with React. React has its own internals to maintain state. So once you start building complex solutions like this can start to get out of sync with the map if you're not careful. The solution that we've taken is to start with a React foundation using React Leaflet, but then build on top of it with the native Leaflet APIs. This allows us to easily construct our map, but then perform complex operations with the data that we want to display. On top of that, there are also a lot of plugins that layer on top of Leaflet that make it easier to do hard things. In this screenshot, we see Leaflet Anti-Meridian. The challenging thing about maps is that the Earth is actually round. So when trying to represent this in a 2D format, your coordinates map to a single area. What ends up happening is like the top here, where the lines look like they're kind of going back and forth across the map. So to fix this, we can use a little bit of math and process the location data, or we can use a plugin to take out the hard work and know that we're actually getting it right. And a more visual example is Leaflet Terminator. It lets you easily add overlay for the day and night regions onto the map. It's just a nice way to visually identify time references. So getting to that point isn't too bad, but let's talk about the data that actually goes into building the map. When dealing with maps, I like to think of a poorly drawn cake. The base map is the actual data, and then you have your overlays as your icing, and then sprinkle some data on top of that. Your base map typically looks something like OpenStreetMap, like we mentioned before, or Modus Terra, and your overlays could be anything like a small sample of high-res imagery or heat maps to visualize data. On top of that, your data can literally be anything such as active fires or evacuation zones. Starting to dig in a little bit further with the base map, this is essentially the map imagery that you have available that covers the entire globe. This will be the foundation of your map. The map images are called tile layers, which are composed of a bunch of small tile images that make up one big large image. If you can see at the top, we have our tile endpoint. There are a few properties that get programmatically swapped out, like date, zoom, and the X and Y axis. The nice thing about this endpoint scheme, though, is it's very common. So we can just as easily swap out an endpoint for OpenStreetMap, for instance. The reason this gets broken up into smaller images, though, is you don't want to have people pulling down huge image files, which the entirety of the map could be possibly over 1 gigabyte in size, where realistically, the person using your map might only use a fraction of that. So overlays are similar to your base map, but a lot of the times they don't have nearly as much imagery available, which is why they're called an overlay. This could be if you have some high resolution imagery for only a little part of the map, or if you wanted to show a different kind of image over your base map, such as a heat map. Here we have an image overlay of the 2020 population density on top of OpenStreetMap. We're showing Europe, and we're on the top, you can see Coimbra, and this is just another example of some of the imagery that NASA provides us. And then we generally have data. Using shapes, we can visualize this data any way we want. Where here, we're adding individual points on the map for each active fire. We can also use lines, circles, polygons. Here we're using a fire boundary for those same wildfires on top of OSM. The points are really helpful to see active fires, but seeing this boundary can be easier to comprehend in the actual area of danger. Point though is there really isn't any requirements for visualizing the data, but there are some standard data formats that interface with Leaflet. Though there are a few, I found that GeoJSON is the most common with my work so far. It's really just a JSON document with a particular schema. The site I'm showing here is geojson.io. It allows you to draw on the map and get a GeoJSON document. But you can see that we just have a simple square. It creates a feature with a geometry type of polygon. Then we have 5 coordinates, which represent the line that's drawn for our 4 corners of the map, going from open back to close. Now, some of the data is free, some of it's not. NASA provides a ton of public data and tile endpoints. It makes it really easy to get started in a kind of plug and play way. I showed you a few of those already, like the population heat map and our base map, but others such as Digital Globe provide open access to limited data. They have an open data program that gives access to imagery for disaster areas. This helps immensely for teams who are trying to put together solutions for help fighting those disasters. But the rest of it would be a premium product that you would have to pay for. And APIs can range from simple to extremely complicated. Most of the time, if you're building commercial solutions, you probably want to roll out your own solution. This way, you can protect your data or have more control over what you're working with. And there are tools to help you do that. Stack, for instance, is an open source spec that help you make geospatial data searchable. There's actually an API that's also open source that makes it easy to make those searches. But say you wanted to make that data private. Since this is client-side, we can require authentication on each request. This also opens the door for data manipulation, where you might want to do some on-the-fly processing based on user controls, and you can end up with some pretty powerful solutions. All right, so once we have our data and our map, on top of that, we need to compile it down and serve it to the browser. This is actually the shortest step of the group. Compiling the app is pretty much the same thing you would expect from anything else built on a Webpack-based app. You can use your favorite tools like Create React App or Gatsby, and those tools compile down to a static site, which outputs HTML, CSS, and JavaScript. Once you have that compiled version, you can serve it wherever you want. At that point, it's just object storage. So whether you want to put it in a bucket on S3 or use Azure's new tool, you really have a lot of options. So what can we build with this? We've been working hard at Element 84, trying to work with first responders and disaster scenarios to come up with a really easy-to-use UI. The goal is that we can get the UI to a point where they don't have to think hard to get the information they want from the map. This is a picture first responder Trevor Skaggs took as he was up against the Camp Fire wildfires in California. There are many natural disasters like this that unfortunately take place every year. It's intense and it impacts people's lives, and we want to try to help. We want to be able to put these tools in people's hands that can actually make a difference. Those tools can help them fight current disasters and be more prepared for the next one. We call this Film Drop DR. This is showing the east coast of Australia. I'm sure most of us are familiar with those bushfire wildfires that devastated the east coast. But we can plug and play really any data source and provide an easy way to visualize that data. Here we're showing the active fires on top of satellite imagery. The hope here is that whether someone wants to look at active fires or the boundary, they don't have to fumble around with advanced settings to get there. After talking with some of the people who actually were working in the field, we determined that we need to get this thing to the point where an operator can understand it in less than 15 minutes. As much as some of the other UIs available have really great granular control, there's just not enough time to try to explain that or simply try to figure it out. With a simple toggle, we can get a completely different perspective of how a fire is impacting our area. This particular shot is from the California Campfire wildfires. We can see the active fire points and boundary over satellite imagery on the top. And we can see the high resolution imagery and the active fires over street maps. Another feature we added is the ability to add data points to the map. If someone wanted to report a missing person, they can easily add this data point to the map and sync it up to the cloud for others to see. The cool thing about this is we can store this locally in the browser. If the person using it doesn't have network connectivity, we can sync it up later. We also want to provide the ability for people to collect in situ data and make it immediately available. Someone with a drone can map out their area, upload it to a computer, and sync it with this app to make that available as a new layer. That can provide some really powerful, up-to-date imagery to better understanding your surroundings. This imagery is actually from a coworker of mine who flew his drone up over Lake Lansing in Michigan. And FilmChop also gets a little bit more interesting on the data side. Not to get down a rabbit hole, but we're building this to be able to upload directly to an AWS Snowball Edge, which is that gray box that the laptop is sitting there. It's basically a cloud in the box, and this gives people out in the field another level of processing power and capabilities that they didn't have before. So what makes this impactful? The hope here is that we can help first responders get the information that they need to be productive and efficient in the field. That could directly equate to more lives saved in many scenarios. So realistically, imagine someone in the area without cell service. They can fly a drone, upload that to the Snowball Edge, and process that to visualize on the map. This can help show things like what areas are impacted by a fire that are no longer safe to go to. That can immediately help save someone's life. Another thing we're working on is an app with one of our customers in the commercial satellite space. So I'm sure we can all agree space is pretty cool, and the idea that these machines are floating around in space or collecting data is just mind-blowing. But how do we collect the data and make it available in a format that's easy to consume? We're working closely with Capella Space. We're helping to provide scientists an easy way to look up and analyze the data that Capella has collected with their satellites. Here we're showing a search of Rotterdam. We can see all the imagery they have available at this time. Once you select one of the results from the search, you can get a closer look and actually overlay that imagery on top of the map. This also comes with a big bucket of metadata. We only get a glimpse of that here, but that's typically more useful for someone who works closely with this type of data every day. If Capella doesn't have the imagery available that they want, we provide an interface that lets them actually task their satellites in real time. Once Capella receives this request, they'll utilize the open and close date to capture imagery of that requested area the next time their satellites pass over that area of interest. Once Capella's satellites successfully capture that imagery, we run it through a processing pipeline using AWS Cloud Services as part of our film drop solution. Here we use S3 buckets for storage. We allow Capella to set up custom lambdas for running their actual science code on that data. The output is a metadata repository that we can put a search API on top. Once they find that data with a search or a new task, they can proceed to order it. The order provides access to pretty much all of the assets, including the imagery. That's usually the high-resolution imagery and a dump of the metadata. We're pretty excited for Capella as they're set to launch their Sequoia satellite. These satellites will collect SAR imagery, which stands for Synthetic Aperture Radar. They'll allow Capella to collect a 0.5 meter range through cloud coverage and even at night. The UI that I just showed you will allow their customers to task this satellite to collect imagery in the areas that they're interested in. So again, what makes this impactful? Well, we're providing a way for scientists to easily discover and analyze data from satellites. This gives them more tools and information to make better decisions that could impact people on this planet. So summer's approaching. We're kind of already here. How about a road trip? Of course, we can have a little fun with maps too. I put together a simple demo that tracks a summer road trip on the east coast of the United States. This is actually a road trip I took with my wife in 2015. Ignore the straight line out to Las Vegas. We actually flew for that part of the trip. but it allows us to get a look at the locations we want to stop at throughout the United States. The cool thing, though, is we can select one of these points and get a little itinerary with a picture from when we were there. Now, how did I put this together? So the first thing I did was start collecting the locations I wanted to work with and put them in a structured data format. Once I had that, I spun up the base of the app using a Gatsby Starter I created with Leaflet. I'll get to that in a little bit here, but for now it's going to be a little bit of hand waving. With those locations, I needed to take the structured data and translate it into something our mapping library would understand. This particular format is called GeoJSON, which I was able to create by mapping over the locations and making the shape groups. I actually needed to do this 2 times. Once in this example where I created the different latitude and longitude points, but also in a separate instance where I put together groups of 2 to make those points create a line. After we have all of our data in the desired formats, we can take those raw GeoJSON data sets and plug them into a new Leaflet GeoJSON instance and simply apply them to the map. You'll notice here that I'm getting the bounds of the GeoJSON, which is essentially the area the GeoJSON data takes up on the map. And once I have those bounds, I can tell the map to view its current view to those bounds. So how about those tooltips? So in the last slide, we showed one of our GeoJSON sets with a custom option point to layer, which I've highlighted here on the side. What this does is allow us to pass a custom function where we can modify the layer being created in Leaflet with our data. So what we're doing is for each layer that gets created, or a point, we create a new marker. Within that marker, we bind a pop-up to it, similar to what we saw in our basic intro earlier. Within that, we create some custom HTML in string format that allows us to set custom content in that pop-up. And with all of that, we have our map with some custom tooltip pop-ups. Not too bad, right? But we can even extend this if we want. We could sync this up to dynamically pull images from Instagram or show a gallery of images during our trip. We can use today's date and highlight where on the trip we are for that day. We can even add a timeline where we can play back the road trip. But to get here, the starter takes out some of the need to bootstrap the app so we can get productive right away with playing with the data. If you're curious or interested in getting your hands dirty, the source code for this is up on my GitHub, which I'll post to Twitter later. That's not a hint to follow me or anything, but I'll also include it with my slide links. And for the last time, what makes this impactful? Well, for me, this was just fun to build. I love road trips and I love working with maps, but it's fun to take some normal event and make it a little more interactive to share with a map. Now, when I talk about we, I really mean all of us. And that's the point I want to drive home, is that any of us can do this. The tools we have available make this accessible for anyone to build. So I mentioned earlier I started that demo with a starter. To help people get productive quickly, I put together this Gatsby Starter for Leaflet. We can very quickly spin up a mapping app with very little fuss and immediately become productive. Using the Gatsby CLI, you create a new project with a Git address. This grabs the project and it installs all the npm dependencies. Then you run yarn or npm develop. This starts your local server. And then we have our mapping app. It's simple. I've been trying to add features little by little, but it's a good foundation to get started with building a mapping app in React. As a bonus, that summer road trip demo can be used just the same as that Gatsby Starter. Similar to the Leaflet one, you can instantly spin up a new road trip app. You would just use the Gatsby CLI like the other starter. I also wrote a tutorial for that walks through setting one up for yourself. It goes step by step through the functionality with split out commits for reference. I'll send out that link with the other resources as well. And you can deploy this right to Netlify if you have an account. That makes it really easy to spin up really fast. And just to note, this works for anywhere in the world. It's not just for the United States. And just remember to update the photos. If you're interested in getting involved, there's a huge community out there waiting for you. You can find State of the Map conferences all around the world. They have a huge community of people working with maps. The interests there range from people actually collecting the map data from people using the map data. I was lucky to go to one 2 or 3 years ago in Michigan as an attendee. It's really awesome to see how passionate people are about the technology. And the stories that you hear will both break your heart and inspire you to do more. So if you want to get involved from an actual mapping perspective, OpenStreetMap gives you a ton of tools to get started there. OpenStreetMap has a vast wiki that helps you get a good idea of what's going on. They also have a nice guided tour that walks you through each of these tools to teach you how to make changes on a map. This screenshot is showing the roads and the locations around the convention center. You can see on the left, we're able to modify the properties associated with each feature. For instance, we can click into the street, And we can see that it's 2 lanes. If something's wrong with this, we can make the changes to help keep things current. You can be part of a huge community of mappers working every day to fix and keep it updated. I found this particular photo on the OpenStreetMap Facebook community, which I just thought was amazing to see. So before I sign off, I want you all to think, how do you use maps? What features do you use every day that you never thought of how it actually works? Maybe the next time that you go to pull up a Google Maps widget for your landing page, you can create your own with Leaflet. And that's it. Thank you. Feel free to ask questions or reach out to me after the conference for more questions.
Thank you, Colby. And thank you for the nice touches you put in your presentation. I saw that you refer our city, the city where JNation started a few times, and you have some image of the map there.
I just hope I pronounced it correctly.
Yeah, Coimbra.
Coimbra.
Yeah. Okay, so let's see if we have question for you now.
That's great.
Everyone, if you have question for Colby, I just want to quickly remember you that you can do it on the YouTube live stream, or you can do it on our Slack channel. And if you are too shy to ask a question now, you can probably ask later on Twitter.
Absolutely, Twitter, or I'm on Slack. Either way.
Okay, so for now, we don't have any question still.
Okay.
People are getting tired as well, I guess. So if we don't have any question, I think we will, we are finished.
Sounds great.
So thank you very much for being with us again, Colby. I hope we can see you physically in a future event of JNation. And thank you all that stay with us up until now. In almost half an hour, we will start our final keynote. So thank you. See you again. Bye.
Thank you, everybody. Thanks, JNation.
Thank you.